Hello all, good morning. This is Dr. S. Subha Lakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and we are on to the topic volume of solids using multiple integrals. In the previous videos, we have seen the finding the volume of sphere and volume of ellipsoid. And now we are going to see the volume of tetrahedron, how we are going to find it using multiple integrals, which is exactly the triple integrals. So firstly, we will have to note the what is actually the equation of the tetrahedron. What is the equation of tetrahedron? It is nothing but x by a plus y by b plus z by c is equal to 1. So this will be the exact shape of the tetrahedron in 2-dimensional area. It is 3D figure, but we have done it in a plane wise. So firstly, we will write the equation of the tetrahedron. This is z by x by a plus y by b plus z by c is equal to 1. As usually, we will find the volume. Here we need not implement this octant or the volume is equal to 8 into the ith value. Here we will find the volume of exact solid here. What is your volume? Volume is equal to triple integral over the region of dz dy dx. As usually, we will be finding the z limits. What are the z limits here? What is the volume here? Volume is equal to triple integral over r dz dy dx. So what is your z limit? Z limit is x by a plus y by b plus z by c is equal to 1. What is z by c? It is equal to 1 minus x by a plus y by b. And what is z? Z is equal to c into 1 minus x by a plus y by minus y by b. And for finding y limit, we will have to put z is equal to 0, x by a plus y by b plus 0 is equal to 1. What is y by b? It is 1 minus x by a, and y is equal to b into 1 minus x by a. What is your x limit? It is your x limit. You have to put y is equal to 0 and z is equal to 0. What will you have? X by a plus 0 is equal to 1. Therefore, x by a is equal to 1 and x is equal to a. Now, we have found all the limits. If we found all the limits, we have to substitute it in the limit of the volume. Volume is equal to triple integral over the region R dz dy dx. What is your x z limit? C into 1 minus x minus a, x by a minus y by b. And what is your y limit? It is b into 1 by 1 minus x by a. And what is your x limit? It is a. So this is how we just find the limits and substitute it in the volume. On integrating with respect to z, you will have z alone within the limits 0 to c into 1 minus x by a minus y by b dy dx. Integral 0 to a into integral 0 to b into 1 minus x by 1 minus x by a. Here they have missed it, and c into 1 minus x by a plus minus y by b into dy dx. We can say take the c common out since it is a constant. Integral 0 to a, on integrating 1 we will have y. On integrating 1 we will have y. On integrating x by a we will have x by a into 1. Integrating y by b we will have y squared by 2 into 1 by b. Within the limits y is equal to 0 to b into 1 minus x by a. On substituting it here, what will you have? On substituting it here, we will have integral 0 to a b into x by 1 minus x by a into b into 1 minus x by a, 1 by b into b square into 1 minus x by a the whole square divided by 2. In each of the terms, we have b into 1 minus x by a common. 1 minus x by a common. So therefore, what we are going to do is we are going to take it out as common term here, and we will rewrite the other remaining terms. So again we will have this 1 minus x by a common here, so we will take it out so that it will become 2 here, square term here. So that integral 0 to b into 1 minus x by a the whole square into 1 minus 1 by 2. What is 1 minus 1 by 2? It is 1 by 2. So 1 by 2 has been taken out. 1 by 2 have been taken out, and bc by 2 is constant. Therefore, the remaining term here is 0 to a into 1 minus x by a the whole square dx. So bc by 2 into integral 0 to a. On expanding it with respect to the formula a minus b the whole square, we will have 1 minus 2x by a plus x squared by a squared dx. So what will be the integrated value here? 1 on integrating, you will have x. 2 by a is a constant, x on integrating x squared by 2 plus 1 by a square, x square on integrating you will have x cubed by 3 within the limits x is equal to 0 to a. So which is equal to bc by 2 into integral on integrating and substituting and writing the upper limit you have a minus 2 by a squared by 2 plus 1 by a square into a cube by 3. Therefore, on simplifying it, you will have BC by 2 into A by 3. Therefore, the volume of the tetrahedron, as we discussed in the firstly, is ABC divided by 6. So, this is how we find the volume of the solids using triple integral. So, here we have found the volume of the tetrahedron is ABC divided by 6. Thank you.